ఇగో నా రోల్ నెంబర్ చూసుకో.
వినబడుతుందా?
Yes, sir. Audible.
Okay. So metric spaces. So in that 18 units is there. Metric spaces, continuous functions, complete metric spaces, compactness and connectedness, continuity and compactness and connectedness, vector and value functions of monotonic functions, infinite products, Riemann stage integral, functions bounded variability, improper integrals, beta gamma functions, sequences, series and functions, Weierstrass approximation, functions several variables, vector valued functions of several variable, Lebesgue measurable existence of non-measurable set, Lebesgue measurable function, Lebesgue integration, Riemann and Lebesgue integrals. These are the units in the real analysis. The metric space. So what is the metric space? I will later find out here. Let R be the set of the real numbers. Let R be the set of the real numbers. So you know that what is the meaning of real numbers? Tell me, anyone. What is the real numbers? What is the real numbers?
Natural numbers.
Yes, tell me proper loudly. Yes. So you can know that the concept of the limit of the real function and the real of the sequence are. So we can take that the x, y, the numbers of the real numbers, we can take that the modulus of x minus y. Am I correct or not? Modulus of x minus y. Modulus of x minus y. I am taking modulus of x minus y. I am taking here. So therefore we shall think here. So therefore the sets of the objects of the rather than the only real numbers, the first requirement of the development of the mathematical analysis. So therefore I did not go into the introduction. I am going to the what is the metric space. So in metric space for all illustration, what is meaning of illustration? Anyone tell me?
Sir?
What is meaning of illustration? What is meaning of illustration?
Imagine.
Illustrations, it is examples. So then the distance between that any 2 points is there always greater than or equal to 0. The distance is 0 only if the 2 points is coincide. The distance point A to point B, the same as point B to A. Further, we have 3 points A, B, C. A to B direct never takes longer than from A to C. And A to B enta dooram untundo, B to A kuda ante dooram untundi. Am I correct or not?
Yes, sir. Yes.
So for A to B directly never takes longer than going to the points A to C also. In triangle ABC, we will take that A to B and A to C. We will in a 90 degrees or anything angles, we will take that the finding angle. So take that here in non-empty set X. Set that if for any two elements X comma Y belongs to X, there corresponds a real number D X comma Y satisfied the some properties here. What is the properties here? If X comma Y Z X belongs to X, so dx comma y greater than 0, dx comma y is equal to 0, if and only x is equal to y. Dx comma y is equal to dy comma x. So dx comma y is equal to dx y comma x. What is this called? It is symmetry or not?
Page number.
What
Yes.
I am asking, I am not asking page number. What I am asking, you tell me. Dx comma y is equal to dy comma x. We can write it or not?
Yes.
Yes.
So it is a symmetry. Dx comma y less than or equal to dx comma z plus dz comma y. It is a triangle inequality. Why? Because we are taking the ABC condition. Am I correct?
Yes.
So I will tell you on the board tomorrow. Don't worry about it. For tomorrow, I will tell you the on the board. Same again. Okay.
Okay, sir.
Now are you understanding? I think.
Yes.
So we note that D is the real function denoted, defined here the set of ordered pairs of the elements X. We call the D metric on X. Thus, a metric space means non-empty set X on which metric D is defined. It is appropriate to write metric space as a pair of X comma D. For any two elements X comma Y belongs to X, there is a unique real number D X comma Y. So greater than 0. Why? Because greater than 0 is called the distance between X and Y is capital X. These elements are metric space or also got points. Why? Because two elements of x comma b, a unique real number. I am telling again, the unique real number, we can take the dx comma y greater than 0. This is a major one. Then examples of the metric space you have to study. This is a major examples r comma n z over z, x bar is equal to x1 x2 xn. So this is examples you have to study. Any doubts, ask me. So I will clarify these doubts. Then subspace. What is subspace? Dx comma d. So entire unit tell not in a day. And this first unit will 3 to 4 days. So only 8 Sundays is there. So that's why I am telling main important. Okay. Hello.
Okay, sir.
Okay, sir.
Okay. Subspace. In x comma d is a metric space of phi is equal not equal to y subset x. Then the metric space D defined x also defined on y. So yd, I am taking the x on d, y on d we are taking here as a metric space. A subset of y, the metric space is also called the metric space. Why? Because y x is a metric space and y is a metric space. So therefore y is also a metric space with a reference to the same metric space x. This metric space is also called by d by y. Thus d by y is a metric space on y. In this connection, we say that y is a subspace of the metric space x comma d. For example, the rational number. What is the rational numbers we have to write? It is q or not?
True.
Q. So it's a subspace of metric space R comma D. So D is the usually metric space. Very important. 1.3 for page number 4. Bounded set. What's the bounded set? Let if x comma D is a metric space, A less than capital X, A not equal to 5, X belongs to X, we define Dx comma A is equal to GLB. What's the meaning of GLB? Tell me anyone. What is the GLB?
GLB.
Greatest lower bound.
Very good. Greatest lower
Greatest
bound dx comma a belongs to a as the distance we are taking from x to a, taking the d of a, capital D of a is equal to lower upper bound dx comma y, up lower bound greater GLB means dx comma a, LUB means dx comma y belongs to the diameter of a. What's the meaning of diameter? Diameter center point to another line. What's the meaning of diameter?
A line which is passing through from the
Passing through
from center.
Center of the
I'm telling you, this is the point. It's a diameter. Am I correct?
Yeah.
I already told diameter. A set whose diameter is finite called is a bounded set. We can later observe that dx comma a is a continuous real function of x. We know that boundness of a set depends on the metric in question. So x comma d is not bound. We can define that another metric d expand bounded respected to d1. So d1 x comma y is equal to dx comma y by 1 plus dx comma y for x comma y belongs to x. So therefore, d1 x comma y greater than 0. Why we are writing greater than 0? Anyone tell me?
Distance is positive.
Yes, d1 x comma y is equal to 0 means?
Maybe 2 points.
same point.
Huh?
They represent the same point.
Same value.
X is equal to y.
X is equal to y, but what is the x value and y value should be the same.
Same.
Am I correct?
Yeah,
Yes.
yeah. And y value should be same.
Yes. So y value is the same. So therefore, dx comma y is equal to 0. So dx comma y is equal to 0, x is equal to y. d1 x comma y, d1 y comma x. I already told x comma y comma x. It is called symmetric. Symmetric or not?
Yes, sir.
Y comma x comma y means we are changing the values in x and y. There is no problem. X comma y z belongs to x not equal to y. So d1 x comma z plus d1 z comma v we can write here dx comma z 1 plus dx comma z, dz comma y 1 plus dz y. So I'm taking the LCM 1 plus dx comma z 1 plus dx dz y, taking the numerator part dx comma z plus 1 plus dz y, and also 1 plus dz y 1 plus dxz. This is a simplification we have done. So that is a simplification you have to do here d1 x comma y. So d1 x comma z plus d1 x comma y. What is the output here? d1 x comma y. So see here. D1 x comma y less than or equal to d1 x comma z plus d1 x z comma y. For x y belongs to z, x comma y comma belongs to z, x not equal to y. So therefore these conditions, d1 is a metric space, 0 less than d1 x comma y less than 1, x comma y belongs to x. We find x1 x comma d1 is bounded. Am I correct or not?
Yes, sir.
Yes.
You have to practice. Any doubts, ask me. I will tell you. Okay.
Okay, sir.
All of you. I am telling. Are you understanding? All of you.
Yes, sir.
It is not algebra, it is a real analysis.
Real analysis.
Yeah. Tomorrow also same timing I will take. Open set in a metric space. Open sphere. If X is a metric space, X belongs to S, R is positive real number. We define S or X, Y belongs to S, dx comma Y less than R in an open sphere or open ball. We center dx and radius sum. An open sphere. An open sphere. What is the meaning of sphere? What is the meaning of open sphere?
There is a 3D picture of a circle.
Yes,
3D dot.
it's also called the neighborhood of X. In the real analysis also we can take that the neighborhood in R. So since X belongs to X, open sphere in non-empty, R is equal to B minus C2, X is equal to B plus C by 2. You have to study open set. For the open set, let X is a metric space, G subset of X. If for each X belongs to G, you can find R greater than 0, SR X subset of G. We say that G is open subset of X or simply an open set. X belongs to R, then the set having a single element
Sir.
is not a. Tell me.
Topic, sir. Topic name.
Open set in a metric space.
Please tell me with page number, sir.
Page number 5.
5. It is 5.
Yeah.
It is real analysis.
So yes, I will explain on the board. Means I will explain on the board tomorrow's class. Don't worry. Okay.
I can't understand, sir.
I did not understood. Again, tell me.
It is real
me.
analysis, page number 5.
Yes.
Yes, again tell me what you did not understanding. Tell me. I will clarify.
No, sir. Problem. Nothing, sir.
Who asked? Venkat Lakshmi asked.
Yes, sir. Yes, sir.
What is the problem? You have to tell me.
What? No problem, sir. Nothing.
Okay.
I don't.
So I will tell on the board tomorrow. Don't worry about it.
Okay, sir.
X belongs to R. X, the single element that R greater than 0, X minus R and X plus R contains the other than X. So X minus R means X plus R. This contains that SRX subset of not equal to X. SRX subset of SRY, but not subset of not equal to X. Why? Because this interval A comma B is not open subset of R. So R greater than 0, SRA is equal to A minus R and A plus R contain that the not belong to AB. We can write A minus R A implies that X does not belong to AB. So this is the not open set in R. You can study. Very most important theorem. An open sphere in a metric space is an open set. See the diagram, all of you. See the diagram. What is the center point to diameter? What is that R? Am I correct?
R, that is the radius.
Radius.
Yes, R, yes, radius. R1 is equal to R1, R minus D of XY, correct?
R equal to
Yeah.
R.
The diameter, D of XY, we are minusing.
Yes, sir.
So, if Y belongs to SRX, dxy less than R, consider a SR1y is equal to R1 is equal to R minus dxy. So, we shall show that here SR1y is subset of SRX. Already I told that Z belongs to SR1y, dyz of less than R1. Dx is less than dxy plus dxz. So, dxy plus dz is equal to that is xy. Xy, yz. Xy, xyz. We can take that xy or not? In the triangle shape, we take or not?
Yes, sir.
So dxy plus r1, that is r minus dxy. So dxy plus r minus dxy, that is equal to r, right? Because plus dxy minus dxy cancel here. So therefore, z belongs to SRX, SR1y subset of SRX, SRX, right? So therefore, SR1y subset of SRX. So almost it is equal to subset. So therefore, it is called an open set. All of you understood?
Sir, here how we should get the d of x comma z equal to r1? How we get
Again ask me.
here d of x comma z which is equal to r? We have to substitute no here, sir. How we get
D
here?
of xz in a triangle x y z. I am taking Amma.
Okay.
What x y z? D of xy plus d of xz. What is that final value?
D of x plus z.
D of xy I'm taking, but three options is there: x comma y comma z belongs to three values is there, x y z. So therefore d of x comma z is less than or equal to d of xy plus d of xz. So xy and xz I am taking. Both are clubbing d of xy, d of xz. Both are clubbing. This is d of xy. Plus I am writing here. Plus. So why? Because plus r1. R1 is equal d of xy. Epudu vastundi d of xy ఎప్పుడు వస్తుంది ప్లస్ r1 minus dxy వస్తున్నప్పుడు d of xy వస్తుంది. Now understood దీప్తి?
Yeah, sir. Understood.
అంటే నేను ఏం చేస్తున్నాను, ఆ పాయింట్ లో d of xy రాసుకోవడానికి సెంటర్ పాయింట్ నుంచి డయామీటర్ లో ఉన్నటువంటి వాల్యూని తీసేస్తే d of xy రాసుకోవచ్చా లేదా?
Okay, sir. Okay.
సో అప్పుడు ఏమైతుంది, సబ్సెట్ అవుతుందా కదా?
Subset అవుతుంది. So we should
సబ్సెట్
write
అయితే ఓపెన్ సెట్ అవుతుందా కదా?
yes.
Very good.
Thank you, sir.
All of you understanding?
Yes, sir.
Only one student are responding. No, a lot of students is there.
No, sir. Yes, sir.
Okay.
Yeah.
Understood, sir.
Okay. If X is a metric space and if G is an open subset of X, then G is the union. What is the union? Means all the members of the clubbing. Some open sphere in X. If G is the empty set, is the union of the empty class open spheres and the results is true. If G is not an empty open set, then X belongs to G. There exists a real number or X greater than 0. S or X subset of G. G is equal to union of X belongs to G. S or X belongs to X. Or X is used to emphasize that or depends on X here. The conversation of the theorem is true. You have to see the next condition I will show here. This one. 1.4.5, 1.4.6. I did not going that you have to study. And it also asked me 1.4.10. What is the limit point? What is the limit point? Anyone tell me? Hello? I'm audible?
Sir.
What is the limit point?
-1 to
Amma tappo righto you have to express. Then I will clarify. Please.
If the point X belongs to capital X is called a limit point of A. If every open sphere S or X contains a point Y belongs to A, then Y does not equal
Y
to A.
belongs to A. What is A? What is Y?
What is A and what is Y?
Suppose Dipti told that Samsung EM, I don't know your name. What's your name?
Sir, Deepti.
No, Samsung EM, one student. What is your name? Hello? Okay. Let X be a metric space, A subset of X. X means a metric space. X in metric space, small x is called as a limit point. Again, I'm telling, in capital X is a metric space, that in a small x is called a limit point. When capital A is every open sphere, S or X points. What is S or X?
Open sphere.
What is open sphere? What is open sphere? It's a circle. Am I correct?
Triangle.
The circle.
I told that in the last problem, circle S or X, subset of S or Y.
Yeah.
S or X contains a point, Y belongs to A, but X belongs to A only can the condition satisfy, but Y not equal to X. Both X and Y, both the variables not applicable here. X belongs to X only variable. That is called the limit point of A, that is called as limit point. X is equal to R, A is equal to 1, 1 by 2, 1 by 3, then is a 0 is limit point of A. Note that it does not belongs to A. So if X is equal to A, B, X belongs to A, B, limit point of A. Note that every point of A is a limit point of A. The two limit points which does not belongs to A. Why? Because set of A is equal to 0 is equal to plus or minus 1 plus or 2 integers does not have any limit point. If X belongs to A, we can find the interval X minus R, X plus R, which does not contain any point either. X is equal to, observe that S 1 by 2, 2, that is 3 by 2, 5 by 2 does not contain any integer other than 2. This is the one theorem you have to, one theorem. If X is a limit point of A, then the open sphere S or X has infinitely many points of A. Limit point A unte S or X infinitely n undochu. Suppose S or X has only finite number point of A, that is x1, x2, and so on, x3, xn. So therefore, the limit point t is equal to minimum d x1, dx minus dx comma x1, x minus x2, and so on, x minus x, and then greater than 0. The open sphere STX does contain elements of A other than X. This contradicts the fact of the X is the limit point of A. Why? Because dx comma x minus 1 and x minus 2, x minus n is greater than 0 అయినప్పుడు అది subset అయినప్పుడు it is a contradicts that the X is the limit point of A. We can write it or not? We can write it or not? Hello?
Yes, sir.
It is not a theory class, it is a mathematics class. Please respond. Closed set in a metric space. What is a closed set? In a subset of a metric space, X is called a closed set of X. Every limit point of is point of M. A finite set has no limit points, and hence it is a closed set. In a particular single point set X closed set, the empty set is a closed set. The interval A comma B closed in R, the metric space X, consider a subset of itself is closed. A subset of a metric space X is closed if and only its complement A dash is X is equal to A is open. You have to study this one theorem and also one very important 1.5.5. A closed sphere is a closed set. Closed sphere means what is the meaning? Closed sphere means what is the meaning?
Sphere along with the points on its it is called perimeter area.
Huh? Who is that? Who is that person? Sunita. Sunita, which study center?
VRAOU campus.
Campus. You understand? You attended offline classes?
No, just one or two, sir. Not all.
Okay. So consider the closed sphere SRX, the complement SRX whole power dash is empty. So therefore, that is the open and SRS is closed. The power means power dash, SRS power dash is empty, hence the SRS is closed. So that is the condition we are taking. The closed sphere is a closed set. Why? Because closed sphere and the closed set open sphere card. It is mandatory. Why? Because SRX power, SRX dash power law, dash means SRX is for X belongs to R power n. You have to study this one. Very important. Cantor set 1.5.10 Cantor set. So we shall now construct a very important set called Cantor set. It has intersecting some surprising properties with illustrate very important concepts of units as well as those subsequent units, measures and the integral. Consider the interval X is equal to 0, 1. Let us try set this is the interval and take the middle third open interval 1/2, 1/3. So is equal to G1, F1 is equal to X minus G1. That is, we are taking the 0, 0, 1/3, 2/3, 1. 2/3 minus 1. So therefore, you get 2/3, 1. In turn, that is suitable. These two intervals, 3 parts, and make the middle third open intervals. We can write G2 is equal to, we can write 1/9, 2/9, and union of, this is one taken, I mean, the example here, 1/9, 2/9, 7/9, 8/9 here. We can write 0, 1/9, union 2/9, 3/9, 6/9, 7/9, 8/9, 1. These are all taken on the unity one. So we can write X minus union of I is equal to 1 to N. This is G, this is called as Cantor set. So the words that we define here, F is equal to intersection of N is equal to 1 to I, N is equal to 1 to intersection and I, so X minus U is equal to 1 to infinity. Gn is the Cantor set, is the union of the closed interval number. Each of the length 1/3. The length of the J is 2a minus 1/3, and I is equal to 1 to 2. The total length of the interval 0, 1. This is called as Cantor set. The Cantor set is uncountable. You have to say uncountable. Uncountable means what is the meaning?
Which cannot, that is like infinite.
Yes, X is equal to dot B1 due to the binary expansion. X belongs to 0, 1. The binary expansion. So Bn is equal to 0, Tn is equal to Bn, Y is equal to theta 1, theta 2. You have to substitute these values. Y does not belong to 1/29. Y does not belong to 7/89. Y does not belong to 0. Exact reversible for Cantor set is the Cantor set is uncountable. Uncountable, the uncountable means it does not belong to. So therefore, it's infinity. That's why we did that writing does not belong. Cantor set is closed. Union I is equal to 1 to N. J is an open set. So therefore, using the theorem, the Cantor set is closed. So Cantor set contains is no segment that you have to study here. Very important. Cantor set is a perfect set. So the set is perfect. Every point of S is a limit point of S. So therefore, X belongs to F, X belongs to N, every N, hence X belongs to IN for some closed interval IN subset of N, Xn not equal to X is the end point of IN, then Xn is point of. Note that all the endpoints of interval IN are in F. Since IN, the length 1/3N, even epsilon greater than 0, we can find N such as 1/3N less than epsilon for N greater than N. So therefore, dxn x less than 1/3N less than epsilon, this is called as Cantor set is perfect. When the Cantor set perfect is dxn comma x less than 1/3 power n less than epsilon, then the condition n greater than n equal to, and n greater than n అయినప్పుడు మాత్రమే perfect అవుతుంది. On which condition? Xn minus x 1/3 power n less than x condition ఉన్నప్పుడు మాత్రమే Cantor set అనేది perfect అవుతుంది. Any doubts in first unit, ask me. I will clarify. Take fast. Make fast.
Sir, Cantor set ante ippudu it depends only that equation only. Fn is equal to capital X minus based on that equation only. Cantor
Yes.
set అనేది definition.
Cantor set అనేది అడగమ్మా. What is your name?
మానస.
Cantor set అంటే అమ్మా, Cantor set లో ఏం చేస్తున్నాము? X is equal, ఇప్పుడు సపోజ్ Cantor set లో ఏం చేస్తున్నాం మనము? Construct the intersecting the surprising properties with illustrate very important concepts. Suppose example తీసుకొని చెప్పండి. 0, 1 తీసుకున్నప్పుడు ఇంటర్వెల్ తీసుకున్నప్పుడు ఏమవుతుంది? ఇంటర్వెల్ తీసుకున్నప్పుడు టేక్ ద మిడిల్ పాయింట్ లో ఏమవుతుంది? అది 0,1 1/3 2/3 G1 లో కనుక ఉన్నట్లయితే మనం తీసేసినట్లయితే మైనస్ కనుక చేసినట్టు 0,1/3 2/3 1 యూనియన్ తీస్తే ఏమవుతుంది? 1/3 2/3 అవుతుందా కదా?
అవుతుంది సార్.
అటువంటిప్పుడు we can find that subdivide these two intervals part with the middle. So therefore అది counter set ఎట్లా అవుతుంది అంటే we can continue this process G1 G2 and close it F1 N2 X minus union of I is equal to 1 to GI. These conditions should be applicable in this counter set.
Okay sir, thank you sir.
Are you understood?
Yes sir.
అర్థమవుతున్నాయి అందరికి? All of you?
Yes, sir.
Okay, please respond. Shall I start second unit?
Yes, sir.
Continuous functions. So aims and objectives. So in this aims, sequences and metric spaces definition we are taking here. N1, n belongs to n greater than 1. The sequences we are taking here. The representative of the form x1, x2, and so on, xn here. So the simply xn, the set of points of sequence is called as the range of the sequence. The range of the sequence bounded set, then the sequence is called as bounded. What is the meaning of bounded sequence? Anyone tell me? What the
Bounded means
sequence?
is it
The boundaries
limited?
Boundaries are well defined. Upper bound and lower bound are defined.
What is the bounded? What is the bounded? I am telling, not boundary. What is the bounded? What is the bounded set?
Bounded means it is limited to some.
The sequence is bounded. What is the meaning of sequence is bounded?
Says x1
Sequence means x1, x2, and so on, xn.
x
X1, x2, and so on is the sequence. Na? No, x1, x2, xn is a sequence. It should be bounded. And up to nth limit is a bounded. Then the sequence called is a bounded sequence. Am I correct?
Okay, sir.
Then convert.
Sir, once again, please.
Yes.
Sequence bounded.
Tell
Sir,
me.
Malli Chappara, sequence bounded.
Yes, sequence bound. The sequence means we are usually t is equal to 1 represent the sequence. Sequence ఏం తీసుకుంటాం? x1, x2, xn కనుక తీసుకున్నట్లయితే అది ఎంత లిమిట్ ఏమవుతుందమ్మా? xn అవుతుంది. అవునా?
Range of sequence.
Yes,
Okay.
sir. Range.
Hello.
Sir,
ఎంత లిమిట్ ఏమవుతుంది?
xn కదా sir.
xn. So that the set of point sequence xn is called. The set of points xn is called range of the sequence. The range of the sequence is bounded, then the sequence called is bounded sequence. Convergent sequence.
Okay,
Now okay?
Now okay,
sir.
The convergent sequence xn being a sequence in the metric space. X belongs to epsilon greater than 0. There exists positive integer n such that d xn comma x for a less than epsilon n greater than n. So the submit the same, we say that the sequence xn. So x is equal to limit n stands to infinity. So therefore n stands to infinity means xn stands to. Tell me. Tell me. Xn stands to x. So uniqueness of the limit of sequence. Xn is a sequence of the metric space. We are writing xn stands to x and xn stands to y. Xn stands to x and xn stands to y. Xn is equal to x and y. So therefore the limit sequence is the xn n greater than n1 dx comma xn less than epsilon by 2 dy comma yn less than epsilon by 2. Both are n greater than small n greater than 1 are equal to n1 n greater than x2. Already told in the first unit dx comma y is equal to dx comma z. I already told or not? మెట్రిక్ స్పేస్ చెప్పానా లేదా మీకు డయామీటర్ లో?
ఓకే సార్ చెప్పారు.
dx comma y less than or equal to dx comma xn plus dxn comma y less than epsilon. This is called also x is equal to y. This is uniqueness of the limiter sequence we are writing here. Just examples you have to note it. One other theorem. Let x be a metric space E subset of x. X belongs to x. Then x belongs to E bar if and only there exists a sequence xn such that xn stands to x. If x belongs to E bar, xn belongs to intersection of E not equal to 5 or epsilon greater than 0. If n is a positive integer, then xn such that Sn belongs to S1 by n x intersection E. We thus obtain a sequence xn such that xn stands to x. Conversely, xn does not belong to xn stands to x. Therefore, epsilon greater than 0, we can find the positive integer here. So therefore, Snx E not equal to 5. Therefore, this is the condition x belongs to E. So this is the one question of your one. Then another very important here, every bounded sequence in R case convergent subsequent. What's the meaning of convergent? What's the meaning of convergent?
Meeting at a point.
Let G be the range of bounded sequence xn is the finite, then we can find R n1, n2 less than x1. So bounded sequence already told you xn, x1, x2, axn. We can write xn here. So E is a finite, we can define n1 less than n2 less than so on. xn1, xn2, we can write x is equal to say. So therefore, if E is finite, then the finite E is the limit point in x in Rk. So Bolzano-Weierstrass theorem, you have to see that 2.3.7 Bolzano-Weierstrass theorem already. I told SRX intersection E not equal to 5 with x belongs to E bar. So the theorem we have to write here. So Bolzano-Weierstrass theorem. So therefore, a bounded sequence is a complete convergent subsequence. So then the set of subsequence Cauchy sequence. What is the Cauchy sequence here? That xn will be a sequence in the metric space X. Given epsilon greater, there is exist of the positive integer n greater than n dxm my xn less than epsilon sequence xn called as a sequence. Cauchy sequence. What is the Cauchy sequence? I am again telling you. N greater than m, small n greater than capital N, dxm minus xn. Dxm minus xn is the sequence of small xn is called as a Cauchy sequence. Earlier x is equal to y we taken. Here dx minus xn we can take out called Cauchy sequence of the data. Every convergent sequence x is a Cauchy sequence here. So therefore, hence small n comma m greater than n, dxn minus m less than or equal to dxn comma x plus dx comma xn less than epsilon. Here also Cauchy sequence. Any doubts, ask me. These 2 to 3 theorems, any doubts, ask me, I will clarify. Make fast. Make fast. No doubts. No
Didn't
doubts.
understand to ask any doubts, sir. So
Again, tell me.
theoretical, so not understanding and following through.
Why? Tell me what is the problem. You have to ask me. I will clarify today. Sunita.
Yeah.
If we read once, we will get doubts.
Yeah, it is not just about reading, but to understand the concept in math,
so I'm
to
telling,
understand
very good.
anything.
Sunita, listen here. I'm interrupting you. In the earlier one, what is the sequence? What we have written x1, x2, xn. We can write down. We can written out now.
What, sir?
In sequence x1, x2, and so on, xn. It is.
Yeah.
Let us take xn is a bounded sequence or not.
Yes, yes.
Bounded sequence.
Here, let xn is a sequence in a metric space, epsilon greater than 0, capital N such that we are taking two values, m comma n greater than n. So we are taking dx x base n comma x base n. Here in sequence, what we are taking x1, x2, xn. Am I correct?
Yes.
In the Cauchy sequence, we are taking dxm comma xn. Small d, what's the diameter? Xn comma xn less than epsilon is a less than epsilon we can call as Cauchy sequence. Now understand. Epsilon means it is a less than one value.
Yeah.
Now clear?
Yes, sir. Yeah.
Ask me if any doubt. Don't not in brain. You can ask. I will clarify.
So it is regarding uniqueness of limit of sequence. I actually what concept just explained, sir. So with
Sunita, tell me.
Yeah, xn a bounded sequence xn, I understood that part. And from the first chapter we know that distance between 2 points, that concept also I understood. So now what is the next step here?
Cauchy sequence
n greater than n. Cauchy sequence, yeah. That part I didn't get, sir. When do we call this?
Again, I will tell you, Sunita.
Yeah, sir.
Am I correct?
Yes, sir. Lost your voice for a second. I know. Yeah.
Now, okay. I'm
Yeah.
telling mobile, one call is disconnected.
Yeah.
What is the subsequence x1, x2, xn? Okay.
Yeah.
Let us call xn. It is called a bounded sequence, correct?
Yes, yes.
In here, xn is a sequence in a metric space X. Epsilon greater than 0, there is exists positive integer n such that exists positive. What is the meaning of positive integer?
From 0 to infinity, integers are defined.
Exactly. So such that n greater than small n greater than capital N. So therefore, we are taking in condition d of xm comma xn. Diameter lo mn values తీసుకుంటే అది less than epsilon means ఒకటి కంటే తక్కువగా ఉన్నట్లయితే that is called Cauchy sequence. Then
okay.
the sequence Sn called is Cauchy sequence. Clear?
Yeah, clear, sir.
Yes.
Deepti and Sunita.
Yeah, sir. Understood, sir.
Okay. You have to. Thank you very much. En is called xn comma xn plus 1, then xn is called Cauchy sequence. If and then other, if every Cauchy sequence is therefore bounded, every Cauchy sequence is there bounded. So see here, the every convergent sequence x is a Cauchy sequence. If xn stands to x, epsilon greater than 0, m such that n greater than n, dxn x less than epsilon. So that is the same epsilon is a Cauchy sequence. Did not to study. This is a first unit what you have to learn in the second unit. In the continuous functions. Tell me anyone, what's the continuous functions? Just a minute, give me. Tell me, what is it? You have 1 minute, give me the time.
Yeah, for continuous functions, we can find derivative at any point.
హలో వీడియో బ్రేక్ ఏంటండి? హలో మేడం.
సార్ కొంచెం ఆగమన్నారు. ఒక 1 minute లో సార్ బ్యాక్ వస్తా అన్నారు.
ఓకే
సరే అన్నారు. అంతలోపు మనల్ని కంటిన్యూస్ ఫంక్షన్ గురించి చదివాము. మీరు తెలుసుకోండి, నేను వచ్చి జాయిన్ అవుతా 1 minute లో అన్నారు.
ఓకే మేడం.
ఓకే మేడం.
హలో.
Yes, sir.
ఎవరమ్మా మాట్లాడు మేడం ఎవరు?
Sir.
Let x comma dx and dy to be metric spaces. F x to y be a function. Dx dy is a metric spaces. Be a function. Let x belongs to a given epsilon greater than 0. There exists a positive real numbers delta. Dx xy less than delta. That is we are writing dy f of x f of y. And dx xy low. dy f of x by x less than అయితే అది continuous function. అవునా కాదా?
Yes. Derivative.
Why? Tell me, Sunita.
For every x, we can find the derivative of it.
Exactly. So therefore, it continues at the point f is continued x, epsilon greater than 0, delta greater than 0 such as delta x subset of s belongs to f of x. Delta depends on the x belongs to s. So this is called continuous function. Definition is, if f is a function from metric space, x is in a metric space y, and if f is continuously in every point of x, then f is said to be continuous on x. This one may be noted. The function f of x is equal to x square in continuous. You have to learn this, study this problem. Any doubt, examples I will explain you. Another theorem, if f and g are continuous real function defined in a metric space x, then f plus g and alpha also continuous, where alpha is any real number. Let x belongs to x, since f and g are continuous x naught, epsilon greater than 0, there exists delta 1 greater than 0, delta greater than 0. D1, d of x comma x naught less than delta 1, g of x comma x naught less than delta 2. ఫస్ట్ దాన్ని f గా రాసుకుంటే 2x minus x naught లే, కానీ ఒకటి f గా ఒకటి g గా తీసుకుంటాం. f of x minus f of naught less than x by 2, epsilon by 2. రెండోది g of x minus g of x naught less than epsilon by 2. if delta is equal to minimum delta 1 delta 2, we are writing రెండు సేమే కాబట్టి x minus x naught లో f of f plus gx minus f of plus gx naught, so that is equal to epsilon. So therefore రెండు సేమ్ అవుతున్నాయి, ఒకటి కంటే తక్కువ ఉంటుంది కాబట్టి f of plus g is continuous, x naught belongs to x. This is one fundamental theorem you have to note. Any doubts, ask me in that one. Make fast. All of you understanding my teaching?
Yes, sir.
Only
Yes, sir.
one Saujanya, only Saujanya till
Yes,
only
sir.
18 members is
Sir.
there.
Yes, sir. Understood.
Okay, very good. I am thankful to
It's clear,
If
sir.
you-
It's clear.
Huh?
It's clear, sir.
Okay. Not wise, my subject.
Subject
Yeah.
only we are telling, sir. We are getting
Very
your
good.
subject.
If f is a function from a metric space x into metric space y, then f is continuous on x if only f inverse g is open x whenever g is open in y. So what is the open? Let x tends to y be a continuous function, g is open to y. F inverse, that is the inverse function we are taking, inverse function is empty, then it is an open set of x belongs to f inverse g, f belongs to g is open set. సో fx x లో కనుక ఓపెన్ సెట్ అయినట్టయితే f ఇన్వర్స్ బిలాంగ్స్ టు g లో కూడా fx అనేది స్మాల్ g లో ఓపెన్ సెట్ అవుతోంది, స్మాల్ g లో కూడా ఓపెన్ సెట్ అవుతోంది. సో see 1 minute, ఓపెన్ సెట్ అవుతుంది. సో దేర్ ఫోర్ అది f ఇన్వర్స్ g అనేది ఎంటీ సెట్ లో x లో అయినప్పుడు f ఇన్వర్స్ g f of x బిలాంగ్స్ టు g లో అయినప్పుడు అది కూడా ఓపెన్ సెట్ అవుతుందా లేదా?
Yes, sir.
అవుతుంది. పేజీ నెంబర్ ఎవరు అడిగారు? పేజీ నెంబర్ ఇది
24.
ఎంతో పేజీ నెంబర్
24, sir.
Okay. So therefore, conversely also we can write here f inverse g open on x where g is open. If x belongs to x, consider open sphere. S belongs to f of x. Let g is equal to s belongs to f of x. Then g is open and y is the hypothesis f inverse g open in x. X belongs to f inverse g. There exists delta greater than 0. S subset of x, subset of f inverse g. Therefore, f of s subset of g. S belongs to f of x. Therefore, it belongs to conversely location open set out on the. So, this theorem is most important. Any doubts, ask me, I will clarify. f of s delta x subset of s belongs to f of x. అంటే అది g లో దానికి సమానం అవుతుంది. అయినప్పుడు s delta x అనేది ఇన్వర్స్ లో కూడా సమానం అవుతుంది. ఇన్వర్స్ లో కూడా ఎందుకు సమానం అవుతుంది అంటే ఆ g వాల్యూ అనేది f of x అనేది బిలాంగ్స్ టు g లో ఉండటం వల్ల ఇన్వర్స్ ఫంక్షన్ కూడా సాటిస్ఫై అవుతుంది. అవునా కదా?
అవును సార్.
కాబట్టి ఇన్వర్స్ ఫంక్షన్ సాటిస్ఫై అయినప్పుడు ఇన్వర్స్ నుంచి ముందుకు తీసుకొచ్చిన ఫంక్షన్ విలువ సాటిస్ఫై అవుతుందా లేదా?
అవుతుంది సార్.
That's all. Any doubts, ask me.
No, sir. It's
Very
clear.
good. Uniform continuity. Definition. Let f be a continuous function in a metric space x into a metric space y. Given epsilon greater 0, if there exists number delta greater than 0 such that x comma y belongs to x, dx x comma y less than delta, dy f of x comma f of y less than epsilon. ఇంతకు చెప్పింది f is uniformly continuous on x. ఒకసారి మీరు థీరమ్స్ చదవండి. ఎనీ డౌట్స్ ఉంటే నేను ముందుకు పోతా. ఇందులో ఈ 2 యూనిట్లలో నేను చెప్పిన ఇంపార్టెంట్ అన్ని చదవాలి. అర్థమైందా?
Okay, sir.
సార్ యూనిఫామ్ కంటిన్యూటీ కూడా ఇంపార్టెంటా సార్?
అమ్మా ఇంపార్టెంట్. ఎగ్జాంపుల్స్ చదవండి, రేపు బ్లాక్ బోర్డ్ మీద నేను ఎక్స్ప్లెయిన్ చేస్తా ఇది.
సార్ ఓకే సార్.
ఓకే సార్.
అర్థమైందా?
అర్థమైంది సార్.
చెప్పండి.
ఈ అసెస్మెంట్స్ ఇస్తున్నారు కదా సార్, అసెస్మెంట్స్ లలో బిట్లలో 2 ఇస్తారు కదా, యాక్చువల్ గా 2 అటెంప్ట్ చేయాలా, 1 అటెంప్ట్ చేస్తే చాలు?
1 అటెంప్ట్ చేస్తే సరిపోతుందమ్మా.
ఓకే సార్, థ్యాంక్ యూ.
ఎనీ మోర్ డౌట్స్, ఆస్క్ మీ.
Yeah, we'll come with doubts tomorrow, sir. We have to go through first.
Yes. అర్థమైంది కదా నేను చెప్పింది?
అర్థమైంది సార్.
అర్థమైతే పేపర్ మీద పెట్టండి, we can clarify.
ఓకే సార్.
రైట్?
ఓకే సార్.
ఎందుకంటే పేపర్ మీద పెడితే నేను ఇవాళ ఇంట్రడక్షన్ మాత్రమే చెప్దాం అనుకున్నాను, టైం ఉంది కూడా చెప్పాను. యూ హ్యావ్ టు డౌట్స్ ఫస్ట్ రైట్ ఇట్, ఐ విల్ క్లారిఫై. డోంట్ వరీ అబౌట్
ఓకే సార్. ఓకే సార్.
తక్కువ యూనిట్లు చెప్పుకున్నా డౌట్స్ చెప్పుకునే పోదాం.
ఓకే సార్.
Okay.
ఇంకా అడగండి డౌట్స్, చెప్పడానికి నేను రెడీగా ఉన్నాను.
So limit point, how can we visualize it, sir?
Limit point. So
if we
X is a
have to-
listen here. What is your name?
Sunita, sir. Sunita.
Let X be a metric space. X, capital X అనేది ఒక metric space అయితే ఏ సబ్సెట్ ఆఫ్ X అంటే X లో ఏ విలువ ఉంటుందా ఉండదా?
X లో
ఏ విలువ ఉంటుందా ఉండదా? ఎనీ ABC వాల్యూస్ ఉంటాయా ఉండయా?
ఉంటాయండి.
లెట్ స్మాల్ x a point తీసుకుంటాను. X belongs to X అంటే అందులో X లో ఉన్నటువంటి విలువలలో స్మాల్ x belongs to X is called as a limit point of A. ఉన్నటువంటి విలువల్లో X స్మాల్ x స్మాల్ y స్మాల్ z ఉంటుంటాయి కదా. So note that it is not, it does not belongs to A. I'm telling, does not belongs to A. But X belongs to capital X, it is called
limit point.
Limit point. But X not equal to Y. But X not equal to Y. X belongs to A. X1 belongs to A. X2 belongs to A. X3 belongs to A. But total not belongs to A. Clear?
Yeah, clear, sir.
Any more? Sunita, here again, X is equal to R, A is equal to 1/2, 1/3. There is a zero limit point of A, but there is no, does not belongs to A. X1, X2, X3 మనం చేస్తున్నాం, మొత్తం ఈక్వేషన్ చేయట్లే.
Yes.
Clear?
Yes.
ఇంకా
సార్ ఇక్కడ స్మాల్ x belongs to capital X, small y belongs to capital A, then A subsidies
again ask Deepthi, ask.
సార్ ఇక్కడ ఏంటి A subsidies X కదన్నారు కదా సార్, A subsidies X, then next small x belongs to capital X, then y belongs to capital A. If both are subsets, A subset then X, then y here
A is a subset, but X is a main set. So small x may or may not belong to
X1, X2, X3, but Y is not belongs to X. Y not equal to X. I'm again telling. X belongs to X means X1 belongs to X. X2 belongs to X. X3 belongs to X. But here, open sphere X or X contains Y belongs to A.
Okay.
But Y not equal to X. X లో ఉన్న వాల్యూస్, A లో ఉన్న వాల్యూస్ లో X1, X2, X3 belongs to X. Y ని తీసుకుంటే Y అనేది X కు సూటబుల్ కాదు.
It is only belongs to A.
Yes.
Y belongs to A,
but
sir.
Total not belongs to A. Deepthi, it is total not belong to A, only for X.
Okay, sir. Okay, now understood. A is subset by X. Okay.
Any more? Any more? 18, 19, 18, 17 members, 29 members is there. So more left. Any doubts? Ask me, I will clarify.
Hello, sir. Saujanya.
Ask me, Saujanya.
సార్ నాకు ఇది క్లాస్ కొత్త, ఫస్ట్ క్లాస్ సార్. ఇంతకు ముందు నుంచి అసైన్మెంట్స్ ఉన్నాయి.
వెరీ గుడ్.
డివిజన్ కోసం
ఇది ఆన్లైన్ క్లాస్ నేను ఇక్కడ డిస్కస్ చేయకూడదు, ఓకేనా? లాస్ట్ క్లాస్ లో డిస్కస్ చేద్దాం, ఓకేనా?
సార్ థాంక్యూ.
yes right. సౌజన్య ఫ్రమ్ విచ్ సెంటర్?
సార్ క్యాంపస్ సార్, కానీ నేను లోకల్ లో ఉన్నాను సార్. సార్ నాది క్యాంపస్ కానీ నేను క్యాంపస్ లోనే ఉంటాను సార్, జూబ్లీ హిల్స్. కానీ లోకల్ లో లేను సార్, నేను విలేజ్ లో ఉంటాను.
ఓకే రైట్. After end of the 9th 8 classes, I will clarify your doubts. Okay.
Okay, sir.
Any more?
Tomorrow also same timing, sir.
Yeah. Thank you.
Okay, sir. Thank you.
Thank you, everyone.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Right,